Welcome back. This is our last lesson on confidence intervals. So we've done confidence intervals for means so far, and we looked at means with big samples and we looked at means with small samples, and today we're talking about proportions or percentages. So to do this, first thing we need to do is a bit of review. In a binomial experiment, there are only two possible outcomes: success and failure. And if you'll recall, P is the probability of success in a single trial, and Q is the probability of failure in a single trial. N is the number of times a trial is repeated, and X is the number of successful trials. A point estimate for P, the population proportion for success, is denoted by P hat equals X over N. P hat means it's the proportion for the sample. A confidence interval for a population proportion is P hat minus the margin of error and P hat plus the margin of error. And the margin of error is the z-value for confidence intervals times the square root of P hat times Q hat divided by N. And of course, C is the probability that the confidence interval contains P. So there's a lot going on there. Let's just break it down by using an example. First, we're going to pull up our confidence level z-values, and then we'll look at the example. In a survey of 1,219 US adults, 354 said that their favorite sport to watch is football. Construct a 95% confidence interval for the proportion of adults in the US who say that their favorite sport to watch is football. So, step one, find a point estimate. So, P hat, the proportion of our sample, is 354 divided by 1219, so about 29%. Now we need to find Q hat, which is just 1 minus 0.29, which is 0.71. Step 3 is to find the z-value for the confidence level. And if we're working with a 95% confidence level, that means our z-value is plus or minus 1.96. And then step 4, we're going to find E, the margin of error. So the margin of error, if we look at our formula, would look like this. Wow. So let's see what this is. We've got probability of success, 0.29, times the probability of failure, 0.71. And that 1.96 is our z-value. And here we have our sample size of 1219. So you plug all that into your calculator, and we get a margin of error of 0.025. So now we calculate the upper and lower endpoints of the confidence interval by taking P hat and the margin of error. So we'll take 0.29 minus the margin of error, 0.29 plus the margin of error, and we get our confidence interval. So P is likely between 0.265 and 0.315. Let's try another one. In a recent survey of 1,256 adults from the US, 226 said that Abraham Lincoln was the greatest president. We're going to construct a 99% confidence interval for the proportion of adults in the US who say that Abe is the best. Step 1, find a point estimate. So we've got 226 over 1256, about 18%. Then Q hat, we're going to take 1 minus that 18% to get 0.82. Step 3 is to find our confidence level z-value. So for a 99% confidence interval, we're going to use 2.58. Step 4 is to find the margin of error. So we use that crazy formula, plug in all of our numbers, and we'll get our margin of error is 0.028. Then we'll calculate the upper and lower endpoints of the confidence interval. 0.18 minus 0.028, 0.18 plus 0.028. So we get the proportion of people who say that Abe is the best is likely somewhere between 0.152 and 0.208. Finding a minimum sample size. Now remember, as you increase your sample size, your confidence interval narrows. And we want to know the smallest sample size we can have that still gives us accurate results. So to find a minimum sample size to estimate P at a given confidence interval, we're going to use this equation. N equals P hat times Q hat times Z sub C divided by E squared. It always sounds crazy, but it's not usually that bad. Let's pull up our confidence level Z values. And this formula assumes that you have initial estimates for P hat and Q hat. If you don't, your default is going to be to use like a 50-50 split. I'll show you both ways. So you're running a political campaign and you'd like to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size needed if a preliminary estimate gives P hat equals 31%. Well, if P hat is 31%, we know that Q hat is 69%. We're doing a 95% confidence interval, so that's 1.96. So we plug all that into the formula. 0.31 times 0.69 times 1.96 over 0.03, that's 3% of the true population, squared. Whew! Thank goodness for calculators, and we get 913.02. Remember, when we're finding minimum sample sizes, we always round up. So we need at least 914 in our sample. Now, what if there's no preliminary estimate available? That's when we use the 50-50 split. So instead of putting in 0.31 and 0.69, we put in 0.5 and 0.5. And we get 1067.11, always rounding up. We get 1,068 people needed. Usually that 50-50 split is a worst case scenario. So that will give you the highest number of all of these. So there we have our last lesson in confidence intervals for proportions. I hope you enjoyed it. I wish you the best. Thank you for being here.